All right, Dr. Greg Kelly, welcome to the Biohacking Beauty podcast.
Thanks for having me here today.
Yeah, I was saying to you that this is the third, you're the third guest in the Young Goose and Neurohacker Collective saga, which obviously started because we ourselves are users of the products and love them and love what they do to us. So obviously, as a company that delivers results to other people, it is in our best interest that their health is dialed in. So we obviously love you guys, and we love having you on, and having you on specifically is a specifically great pleasure.
Well, thanks.
Yeah. So the reason we reached out and wanted to have another podcast with you guys is mainly because we were very excited with your release of the NAD boosting product, which obviously is at the heart of what we do at Young Goose. That's kind of how we started. And I think the question, what should you do internally to boost NAD, comes up probably in every conversation that someone learns what we do is a skincare product. What took you guys so long? That's the question.
Well, it's actually our second product, Quality of Life, has what we would think of as an NAD boosting stack built into it as a core part of that. And so right after Quality of Mind, right, that was the first product after Quality of Mind that we brought to market. And so for a long time, we felt like, okay, we had that covered. And then what we have seen is, despite that product actually working well in a study where we measured before and after NAD, there's almost too many benefits in that product, and it was getting lost that it also did such a good job on NAD. So we decided, well, let's just do a targeted NAD product. Some of our clients want that. Some of us wanted to do a bit more than Life offered, and so that led to what's you mentioned is now on the market, Qualia NAD Plus.
Yeah, that's it. And I just started taking it, and I'm very excited. We're gonna go probably like about the different ingredients that excite me specifically, but maybe we should start with why was it important for you guys as a kind of a holistic approach company trying to improve the entire human organism. Why was it so important for you guys to create a product that addresses NAD in the body?
I think when I think of Neurohacker Collective and the Qualia line specifically, it's really about two things, right? It's about performance, and it's about making products that people can experience a difference with. Though we would say they feel the product in some way. And NAD is just so intricately tied up in so many areas of cellular performance. And really, like as a naturopath, the core premise is, right, the health of our tissues dictates the health of our whole system. And really, it's at a cellular level, right? That's the most fundamental unit of life. It's the health of those that dictate the health of our tissues. And NAD just plays so many roles in keeping cells healthy. And just for the audience, a few of those big ones are making energy. Number one, that's its role in ATP. Another one that's often not talked about as much is its role in cellular protection. So antioxidant defenses, detoxification. That happens when NAD gets a P tagged onto it and then goes into that direction. And then this is newer info, like new, not this year, but in the last 2 decades, that NAD also plays roles in repairing DNA, super important in our skin. Also in what are called stress response signaling, sirtuins being the classic example. And again, super important in keeping skin resilient to stress. So I know we had Charles Brenner, the person that discovered how NR is made into NAD on our podcast not too long ago. And the way he always describes NAD, and I think this is the right way to think about it, is that NAD becomes super important, more and more so when there's metabolic stress on cells. And you think of the skin, right? The skin is just stressed metabolically by so many things.
Yeah.
in the environment, which is one of the reasons, as some of your listeners know, that NAD metabolism in skin is so critical to skin
Yeah.
aging in a healthy way.
Especially, I mean, I don't want to get ahead of ourselves because I wanted to kind of introduce people slowly to this conversation, but I have to address it, especially as we grow older and we accrue more unrepaired damage in the DNA level. Because I think the skin, as opposed to your liver or your heart or your brain, gets damage which is not only chemical but is mechanical damage. I mean, UV passes through our DNA and fuses parts of it together, right? And as we grow older and that damage just is a chronic type of stressor, NAD is almost robbed from our natural, repair and maintenance process, and really is hijacked by this snowball effect of accumulated damage.
Yeah, for sure. So a few things that science would know, I think fairly certain, right? That just writ large in our body as a whole, NAD, the pool of that molecule tends to decrease progressively as we get older. But then some tissues are disproportionately impacted, and skin would be one of the first drained, right? Because as you mentioned, it's when cells are stressed, whatever the stress, that they'll try to pull NAD from wherever they have it to protect themselves, right? To detox, to protect themselves. And we may touch on it in this podcast, but we have quasi-senolytic, right? And the idea there is something called senescent cells and fibroblasts, immune cells. Those were two of the first cell types that, and at one point thought to be the main ones that become senescent when stress is too much. And if we don't have enough NAD, the cells can't respond resiliently to the stress and instead become senescent. And we don't want senescent cells to accumulate in our skin if we want to have, vibrant, healthy skin as we're getting older.
Yeah, definitely. I mean, this is in our best interest to explain how senescent cells in your skin really affect your whole body. They can affect your brain, etc. But and I specifically take quasi-senolytic, which I brought here to show because of that. But I want us first maybe to talk about, kind of my first question was what took you so long, but what took us as a scientific community so long to decipher the NAD, the importance that NAD plays in our body. Because almost for like 80 years since it was discovered, or actually for 100 years, 80 years since someone got a Nobel Prize for its discovery, it was only thought of as a electron transporter, right? Like as a energy facilitator, if you would.
Yeah. So the really 80s are the most right. Like late 1930s is when niacinamide were both discovered, like back-to-back years, and the classic deficiency from B3, was before that. Pellagra is what it's called, and it's the 3 Ds is how you classically think of that, right? And one of the Ds is dermatitis. So like a vitamin B3 deficient, very prominent skin issue. So the connection to skin existed before we even knew the molecules, right?
Yeah.
And it was, I think, like niacinamide, one of what I think of as the OG, or one of the OG forms. Has obviously had quite extensive research topically and orally for skin health. But I think what happened just in a historical sense is when I would have taken biochemistry in 93, would have been my first year of naturopathic school, the main roles of NAD would have been two. So that NAD, NADH, right? So that it's called a redox pair. And that's super important to carry the hydrogen to make ATP, right? So that energy metabolism. And the other one would be NADPH and NADP. So same redox kind of idea, but with a P added on. So slightly different molecule. And that's the one that instead of energy, it's involved in antioxidant defenses. So glutathione being something I'm sure you would know about, and detoxification because of that. So those were the only things in. And then in the late 90s, it became much more well established that in addition to those redox roles, so when you think of redox for the listeners, the molecule is just going back and forth, toggling between two states. So you're not really using up the molecule, so to speak. But they then identified these, what are called consumption uses, where the NAD molecule, instead of going back and forth between two states, is literally kind of gobbled up and broken into pieces. And one of those consumption roles is the DNA repair that you mentioned. One is activating sirtuins, which are a stress signaling system inside cells. And one has to do with inflammation. And so with that, I guess, that understanding, then all of a sudden it's like, wow, we weren't thinking broadly enough of why this molecule could be so important. And that caused, starting in that late 90s, just a boom in interest in NAD. But I think then the key landmark study was 2013, and it was led by David Sinclair, his lab. And what he found was in older mice, if NAD was boosted, then their mitochondria performed at the level of younger, healthier mice. So like fundamentally, it made old mice perform it more youthfully. And that, I think, is what really then caused a crazy propulsion forward in interest in boosting NAD, and like the birth of companies like Elysium Basis came out right after that because of that study.
Yeah, it's funny, Elysium Basis did such a nice job explaining, I guess, the science at a fundamental level, at a consumable level, that they took this very kind of hard to explain molecule, because they took NR basically and ran with it. I mean, more than the producers of NR, which you mentioned, which is interesting, because it is not a straight shoot, right? Like a lot of things in our body, it's not like if we want, the joke is, if you're going to eat a banana, you're not going to have a banana growing from your forehead, right? It's not a straight line between what you eat or what you consume into your body and the molecule that you end up using. And the same holds true for NAD, right? It's not like we can just take NAD and our body is going to just, allocate it to wherever it needs to.
Yeah. So I guess like stepping back in animal products, like, meats, eggs, dairy, there'll be, so the way science would describe it is, think of, there's NAD, and then there's all the molecules that make NAD and all the things made from it. So often that would be thought of as the NAD metabolome. So the ohm, and that's the same idea as the gut microbiome, right? The collection of all the things related to it. And so one way I think about it is NAD, let's just, like, it's a network of molecules fundamentally. So like a network might be airports in the US, right? And in that network, there's some really big, super important airports and some that are really small. So like, as an example, I live in San Diego. Our airport's big, but not LAX or Dallas, Fort Worth, or Chicago here, or one of the New York airports. I've lived in Santa Barbara. Their airport's super small, but if I get on a plane there, I can get eventually to where I want to go, right? So when you think of NAD, that molecule, think of that as maybe the biggest airport in the system. But what we want to do is, no matter where the passenger gets on, maybe they get on at NR or NMN or, one of the old niacins, niacinamide or Flushing niacin, we want to make sure that they move through whatever airports they need to get to NAD. And then we want to make sure they don't get stranded at NAD, right? We want them to move forward to that NADH version or to the NADP version, or to be consumed, at the airport that does DNA repair. And so when I think in terms of, like boosting NAD, and what I would think somewhat distinctive about Neurohacker is we're like, okay, well, what do we need to do to support the flights going between these places as well, right? So what would happen classically, I guess rounding back to your point, is that in meat, you'd have big molecules like NAD, but you'd also have some of the other airports. in most vegetables, you're not going to have the big molecule. You'll have usually like a form of the flushing type of niacin, but bound to other things, so it's not as well absorbed. And molecules like NAD are really big. So when we digest meat, we don't uptake the whole NAD molecule. We just reuptake parts of it and then remake it after it journeys through our blood. And so, when I think of, why does it decrease with aging? It's not so much because our diet changed, right? We're still, largely probably getting as much in our diet as a 20-year-old that has much higher levels. But if we do more, if we fundamentally put more of the building blocks into the system, then what you'll see is more gas to that hub airport.
Yeah.
So go ahead. Sorry.
Yeah. So what really, how are we perceiving that depletion of NAD? Why do we see it, reduced significantly? Obviously, since our 30s, but but the classic phrases, by the time you're 60, you have half of what you started with. So why is that?
Yeah, so there was an interesting study. So there's a few different reasons potentially, but one of my favorite studies was led by James Clement. He's a famous longevity researcher, and it was something along the lines, the title was "The Plasma NAD Metabolome is Dysregulated with Aging." I probably have a few words wrong, but general gist of it. And so it was in plasma, wasn't in tissues, but what they found was that, as they expected, with age, NAD levels were lower. So the older group much lower than the young group. When they looked at some of the other airports in the metabolome, some of those were also lower with age. But when they looked at certain, like the whole metabolome, there was airports that had way too many passengers, right? So fundamentally. And I know when I looked at that, I tried to make sense of it. Like, why are these passengers stranded here and not getting to the next leg in their journey? And what was always the case, the enzyme, the thing that converts one to the next in the line, so fundamentally the plane that would take them on the next step, when ATP was in that enzyme, there was always a buildup on the front end and too little on the back end, right? And so what that would translate to is, just as we get older, we're probably not efficiently making ATP in all of the places we need it. And so we can't move these molecules to the next stage of their journey. Right? So that's one big reason. The other is, one of the consumption uses has to do with this molecule called CD38. Yeah. And CD38, your audience has probably heard the idea of inflammaging, right? This idea of like low level inflammatory processes that build up over time as we get older. And those basically deplete the NAD pool. That consumes a whole bunch of it. And so kind of robs what we would need to stay in equilibrium when we're 20 or 30 isn't sufficient when that happens. And then the third idea I would just say is stress. Like our cells, our physical cells as well, typically the resilience to stress lessens as we get older. And stress, one of my favorite ideas from Cellier, the grandfather of biological stress, was this idea that stress accumulates, right? There's no such thing as like going back. If we stress a system, it doesn't ever go back to the way it was before. And so the idea was stress leaves a scar. And I'm old enough that I had vinyl records, and I think of it as it's a scratch on the record. No matter what we do, we can't unscratch that vinyl album. We can only, over time, add more and more scratches if we don't take good care of it. And as we're older, that's typically happened. So that combination of things, like the flow through the complicated airline system, isn't working. Passengers are getting stranded. The amount of the molecules that were sufficient when we were 20 are insufficient because of stress, inflammation, other things as we get older.
How would you describe in that system? How would you describe CD38? What would you call it? Maybe the TSA? Like what would you call the CD38?
Well, I would say it's almost like planes are going to the wrong airport. Too many of the passengers, want to go to New York and are going to Florida instead. Right? They're just getting diverted somewhere. Maybe a snowstorm. Like who knows, right? But because of that, one or more of the other important places in the system aren't getting their passengers.
Yeah. Okay. So, why do we, obviously we are in a society that wants first and foremost to understand why our bodies are not perfect. I think it's a lot of discussions within the health space. A person first needs to understand that their body, I think fails them is a big word, but their body is not performing up to the level that it needs to do to maintain, homeostasis, optimal health, whatever you want to call it. So why is our body not able to, eat enough food and replenish the levels? What are we missing there?
Well, I think there's different theories of aging, and often two camps. Like you can put the different theories in one or the other. One is what would be thought of as the damage accumulation camp, and the general idea is that the more time has passed, the more damage we've accumulated in cells and tissues, and because of that, we can't make the same things we needed to stay in the type of homeostasis we had as a 20-year-old. The other would be a camp that's called programmed aging. And the idea of that is that really, evolutionarily, the important thing is that we pass on our genes to our offspring. And once the window of time has passed for that, keeping us alive isn't as important. So we're not evolutionary programmed for healthy old age. So a lot of the things that, the performance things that fall off with age, it's almost like the software program just starts running like, okay, instead of young, reproduce variant, it starts to like old, tired, worn out, let's get rid of me variants.
Yeah. Yeah. Interesting. Yeah. And we do see a lot of processes within the health, within the hallmarks of aging. A lot of processes, you mentioned senescent cells, are actually kind of a process to help you to keep you younger when you're young, but they kind of turn on you when you're older. I mean, mitochondrial decline is another. So before we get, because I'm itching to get to the product and the way that you guys conceptualize it, but I think we owe it to people to first ask the question. So what can people do, as far as lifestyle, in order to support NAD levels? Because it's quite interesting that, for example, lower calorie intake actually begets higher NAD levels, right? So what are some of the things that we can do lifestyle-wise to increase NAD levels?
Well, like as an example, if we wanted to, things tend to be adaptive, right? So you mentioned this idea that, like our body kind of lets us down. My fundamental story is, like, I would use the phrase trust my body. Like it's doing the best it can. Now that best I may not like, but it's doing the best it can with the circumstances that it's in, the resources it has available. And so, my story is always like, thank you, body, right? And adaptations tend to be super specific. So as an example, if we, weight train, train for some, endurance event, what would naturally happen is our system will try to upregulate making more NAD in those muscles that it's using, right? Because, NAD, one of those roles is energy production. And there'll be then some bleed over into other tissues from that as well. Anything we're doing that's like adding to the stress burden, right? Lack of sleep or, you name it, is going to deplete that pool of NAD. In general, you mentioned lower calories. So calorie restriction would be among the most, if not the single most studied intervention for trying to extend longevity. Most of the studies are, rodents. And they're interesting, but, I wouldn't say, I would assume they don't really translate to us. And part of the reason I have a book called Shapeshift, I did a lot on kind of, shape, weight, and how our body responds. And if we do things to make ourselselves hungry, so if we're feeling hunger all the time, then there's a whole bunch of other adaptations going on as well, right? Our metabolism's slowing. So fundamentally, it's super hard to live hungry for
Yeah.
any sustained amount of time. So that's not really an achievable thing in humans unless you do what they do in the animal studies, which is they literally control every amount of food, right? Those animals, if left to their own devices, would eat a lot more. So,
Yeah.
but what happens in any of those types of things, it's almost like that reproduction longevity axis trade-off, right? So
Yeah.
the idea would be, okay, well, there's not enough, calories, to optimally support nutrition. I better slow everything down so that I
Yeah.
can, have more time to reproduce my DNA. And so I think the way you get there in non-calorie restriction is other things that send signals to cells, right? And polyphenols, as an example, like a big part of how qualia-senolytic works is it's crazy high amounts of these specific polyphenols that send signals to cells, and then the cells, in a sense, say, "Oh, like the environment's looking like it's not great." And so I better get rid of the cells that aren't pulling their weight and, send all those resources to ones that are.
Yeah. This is a very interesting concept, the one that you're talking about, which is, as humans, we're kind of terrible consciously receiving messages from the environment. Like, we don't know when a solar flare is happening. We don't know where there is stress on plants. We really don't know any of that, visually or with our senses that we can perceive. But we have pre-programmed responses to stress signals from plants, which is pretty interesting. So from the plants that we normally would consume from the environment around us, we can sense stress from them, and our body responds to it, which is pretty interesting. And you mentioned polyphenols as one of them.
Yeah, polyphenols just in general would be plant defense compounds, right?
Yes,
so
yeah.
Plants make more of them when they perceive their environment being more stressful. I remember this probably goes back 15 or so years, but it was a study that looked at capsaicin, the spicy principle in peppers, and it being produced. And what they found was, if aphids, which are an insect pest, were on a nearby plant, the other surrounding plants made more capsaicin as a way to deter aphids from consuming them.
Yeah.
Right? So, resveratrol, again, fairly well known. It's the polyphenol that you hear a lot about with wine and grapes. But that's, if the environment's harsher, right? Drought, too much sun, you name it, then grapes will naturally make more resveratrol as a way to protect themselves from stress.
Yeah.
And as you mentioned, then when we eat those plants with the more resveratrol, the signal it's thought to send to our cells is like, oh, their environment's more stressful. That likely means ours is going to be more stressful. We better get ready.
Yeah. Interesting. So let's go now. I really want to talk about the way you to kind of try to get into your mind when creating a product that, as you said, is a very complex supplement, because it doesn't only straightforward, here's your NAD building blocks, good luck. It makes sure it ticks all the boxes within that flow of passenger, if you would, in the transport system of NAD. So let's start with, obviously, the NAD building blocks, which is also interesting because you guys have more than one, which I'm not sure that I've seen before in an NAD boosting product. So what are those?
Yeah, so there's a couple different ways. So again, just think airports is a useful thing. Like, you can get to the LA airport from Santa Barbara, from San Diego, from Arizona. Often what brands will do is just choose one airport, give that particular building block, say NR, which is a great building block. But what happens in our cells is that it's called, in complex system science, it would be degeneracy is the specific word, but think of it as redundancy. For important things in our cells, is more than one way to do it.
Yeah.
And so, like the flushing niacin is an example, that is its own path to get to NAD. Niacin goes to NMN as an example, and then NMN. And R goes through a different way to get to NMN. So, my belief is when cells are choosing to have multiple ways to do a job, it's better to support all those ways. Again, like I said, I trust my body. It knows better than I do. I just want to make sure it has resources available to do all the things it's trying to do. So that's the general idea. And then the other thing is, and this hasn't been looked at as much, but the gut microbiome's super important with the gut skin axis as an example, right? And I mentioned that some of these molecules are big. We don't absorb all the NR. Some of that gets to the gut microbiome, and that has a different, fundamentally some different microorganisms that would say, "Oh, yummy, dinner's here." Then maybe the flushing niacin, right? So by giving that whole package of support, I think we're also more broadly supporting the gut microbiome, and that's an even more complicated system, right? Crazy, complicated, and I think we want to feed as many of the different good guys as possible.
Yeah, that's very interesting. One of the things that is interesting to me, looking at the ingredients, especially when we're talking, for example, about that blend that you guys have between niacin, flushing and non-flushing niacin, which you mentioned is called niacinamide, is that you mentioned where you make it from, okay, where you make it from bacteria. Why is that important to emphasize in a formula? Is it just for us for the formula to look friendly and to understand it comes from good sources, or why is that important to emphasize?
I'm not sure I understood the question.
So here it says from culture of cerevisiae. So why is that an important factor to mention?
Yeah. So one of the things we did. So I mentioned earlier that NAD makes ATP, but we need ATP to move things through this complicated system. And fundamentally, there's two things for the listeners, I think, to take away. Whenever you hear ATP or see ATP, always think magnesium ATP complex, because in our biology, ATP without magnesium attached to it doesn't do anything, right?
Yeah.
It's that pairing. So we have magnesium in because of that. And then to turn the, fundamentally the sunlight energy that's stored in plants and animals into ATP requires the entire family of B vitamins. So we have those in, but we chose to put those in as a food source from a specific type of yeast, right? And so think of it as a B vitamin or B complex vitamin enriched yeast. So that's the Saccharomyces cerevisiae culture. So what they do is they would put these B vitamins in the growth media, and as the yeast grows, it just incorporates those. So yeast, like us, would have the whole airline, like airport system in there. So it's going to give, in like using that, right, as the way to give the B complex, gives the whole system of airports. And like I said, it's the flux through these things that at the end of the day is what we rely on. Like obviously NAD and having more is the key thing we focus on, but we don't want passengers all to be stuck in Dallas, right? I've been there overnight, not fun, right? So, so that's why. And then we label it that way because we have to say where things are from for non-standard things, at least.
But I love that because I have a theory that most supplements that we're trying to get our body to use, they have to come with an entourage, basically. Obviously, we know it. What I mention a lot is CBD. If you have an isolated version, it's only 10% as effective as a broad or full spectrum version. And I believe we can see it. We now start seeing it with things, for example, like spermidine. It needs to have the entire gamut of putrescine and spermine in order for it to boost autophagy levels. But I think that we're going to find that the same goes for anything from vitamin C to niacinamide and B vitamins as a whole. So I love the fact that you introduced it like that. but you did mention something interesting, which is kind of helping the passengers move along. So what other ingredients did you introduce into the formula that are helping, the utilization, the actual function of the body, utilizing those, NR that you mentioned, niacin, niacinamide?
Yeah. So no matter like what airport we started from, the NR1, niacin, even NMN, if that was the starting place, the last step, right? The enzyme is a group of 3, and it's called NMNAT is the thing, and then 1, 2, 3. And NMNAT2 is widely expressed in the brain. The one can be in a lot of other tissues. And so one thing that caught my eye, so fundamentally you could, as an example, giving NR alone increases NAD, right? Well studied at this point. But there's a molecule before that called NAD that goes up even more. So you're kind of creating almost a bottleneck, like a lot of stranded passengers. And one thing that caught my eye was a study that it was in animals, so preclinical, but they gave NR, or they used NR and caffeine in this particular study. And the reason was because caffeine is one of the only things that's been shown to increase the activity of that NMNAT2 enzyme in the brain. Right?
Nice.
To no matter how you got to NMN, make sure NMN gets on the plane to go to NAD. And so what they found in this study is that on its own, caffeine increased NAD and I think it was astrocytes, but brain cells, because it was, moving passengers along. But if you added NR without caffeine, that did as well. And if you put the two of them in the cell culture, they were complementary. Like more passengers got to where they wanted to go.
Very, very interesting. And that was in rodent?
That was this was in vitro, so it was a cell culture where they added I think it was both brain cells and then there was one other cell type, but that NMNA2 is it would be the brain variant of that enzyme.
Yeah. So you mentioned that you have magnesium for that ATP to really be utilized by our cells.
Yeah. So I was just going to say.
No, go ahead.
If we were to start at NR, as an example, both enzymes that it has to go through to get to NAD require ATP. If we start at niacinamide, one of the 2 requires ATP, and if we start at flushing niacin, 2 of the 3 need it. Right.
Yeah,
it's just crazy important, and so I never hear anyone talk about that's needed, right? And I fundamentally believe a big part of the issue with aging is that too many passengers are getting stuck at the airports on the front side of ATP and not making it to the next place in their journey. And magnesium deficiency, as you would know, is just not outright deficiency, but not getting quite enough is super common. And in a general rule, there's something called the magnesium stress vicious cycle. But the general idea is when we're stressed, we flush more magnesium out of our cells into the extracellular space, which then if we don't do things to correct that stress, then we deplete intracellular magnesium, and that makes us more susceptible to stress, hence the vicious cycle.
Yeah, and we actually have a lot of evidence, talking about skin health, that magnesium, deficiency, even slight deficiency, increases the damage MMPs, which is a derivative, or this is a byproduct of more stress. If we would the damage they wreak on the skin. So it's pretty interesting to see how anywhere we turn, really, we find that magnesium could have helped. Let's say it like that.
Yeah. So for sure.
Do you have how are you approaching choosing the type of magnesium, or what would you choose in order to support that process? Because
so in this particular product, we're using a magnesium called Aquaman, and it's a seawater derived one that has 70 trace minerals that would also be in seawater. And the I think of it like you probably know this, but the number one source of magnesium on the planet is the hydrosphere, right?
Yeah.
Oceans, mineralized, inland lakes, ponds, things like that. And so, up until probably relatively recently with bottled water, like at least a good chunk of our magnesium intake was magnesium rich mineral waters and other things that we would have naturally had. And in those, magnesium is going to be packaged with all these trace minerals, right? And our cells, our mitochondria evolved in the ocean. So our general idea is we don't have any idea what actual function all these trace minerals have. We just know our cells evolved in an environment that required them, mitochondria as well. So rather than just giving magnesium, and there's good magnesiums, right? Lots of good chelated, forms, but let's give it with all the trace minerals, because my intuition is that's ultimately there's a contribution there to mitochondrial performance that we just don't know yet.
Yes. Interesting. The only other place I saw Aquaman was a creamer by this guy, the surfer guy, I forgot his name, but Laird Hamilton. He has a creamer company, and they had Aquaman. So it was I was pleasantly surprised to see it. I do have as someone who uses a lot of you guys as supplement, you chose to use trans resveratrol here as the I would say some people call it, if NAD is the fuel, resveratrol is kind of the gas pedal for those sirtuins or enzymes that NAD interacts with. Why would you choose resveratrol? First of all, how do you describe resveratrol?
So I think of resveratrol first and foremost as it's a plant defense compound, right? As we talked about, and the term for what you were describing earlier, where plants in our environment are stressed, we consume them, it sends a signal to us, is often termed xenohermesis, right? Like a hermetic thing, but from the plant kingdom. And I think for sure resveratrol is one of those. I think there's good science on that, and so because of that, it does a lot of things, right? It's sending a message to cells, but one of those, there's the connection that Sinclair has been making for quite a long time. David Sinclair, for the listeners, with the sirtuin system. But another is upregulating the enzyme that's called the salvage of NAD. So, after, like as an example, NAD molecule might be consumed to repair DNA, and that in that consumption it's broken off, and what's left over is just the niacinamide, and so that has to be what would be called salvaged, right? Like turned back into ultimately NMN, and then NMN into NAD, and the rate limiting step in that is an enzyme called NAMPT, NAMPT for short, and resveratrol would be one of the things that activates that enzyme, so to speak, right? It makes salvage better. So that's the main reason we have it in this particular product, is to support that, again, flow through the system.
Interesting. And why would you choose, and this is really semantics, it's just interesting to me, because you do use, for example, it has been used, pterostilbene, for example, has been used by, we mentioned Elysium, I think they use pterostilbene, mentioning a company that has more than one ingredient in their supplement. So why would you choose resveratrol over pterostilbene for your formulation?
I think in terms of the amount of studies on one versus the other, it's not even comparable. Resveratrol is just one's a mountain, one's an anthill, so to speak, right? So so that's the main reason. Another was we felt for some less sophisticated, so not your audience per se, but a less sophisticated may recognize resveratrol, probably wouldn't recognize pterostilbene. But at the end of the day, more than anything, it's what's likely to make the product work better, because we care about that. And so the other thing I think of, at least my opinion on resveratrol, I think more often than not, we tend to think in a more is better mindset. like I have friends I used to joke with that were, IT people, and, like I think of going to, southern Spain. I go there, maybe once a year, and you get these little servings of just a delicious coffee. My
Yeah.
IT friends, they just want the biggest Starbucks thing they can get, right? So
Uh-huh.
like my idea is, like quality is the most important thing. Theirs is quantity, right?
Yes.
And so I tend to think most things more isn't better. Like the idea too
Yep.
much good might be no good, and that there's a Goldilocks principle, right? A just right amount. And for things that are in that hermetic world, which I believe most polyphenols are, resveratrol certainly, that we want to be in that zone. So
Yeah.
I think I see not infrequently, some influencers or products with an amount of resveratrol I personally wouldn't take every day for month
Uh-huh.
after month after month. So when I create the amount of something in one of our products, maybe this analogy would help. It's called the Yerkes Dodson lots, an old law, and caffeine was the initial thing they studied. But think of an upside down U
Yeah.
for the audience, right? And it's a performance curve. So when you
Yes.
get to the top of the hill, that's like exemplary performance. And along the bottom is often the intensity of something. So with exercise, that would be the amount, or the how fast you're running. So most things, or at least many things, probably far more than the listeners realize, track through that curve over time, because that's really what the bottom is, right? Time and intensity. So quick story, if you and I said, hey, I've got this great idea, let's run a marathon every weekend for the next year, right? We track through that curve really quickly. Like performance would peak and we'd be in a world of hurt, most likely, right?
Yeah.
But if we said, let's walk, a mile every day for the next year, we'd probably be still climbing up to peak performance a year from now. So when you think of like anything, always think of this idea of intensity and time. The more intense something is, the more likely you'll track through that performance curve in less time. And when supplements, intensity translates as amount or dose.
Yes.
Right. So if you want to spread out, do the equivalent of, walking instead of a marathon, you take less of something and you get the benefit longer. If you go for these ridiculously high things, I mean, maybe they'll work for a while, but I think you run the risk of now fundamentally overtraining to that.
Yeah, I think one of the most hilarious kind of accidental jokes of the year was this Australian comedian that was on some podcast, and the podcast was health conscious, so they're explaining to him about ice baths. So he goes, oh, it's good for you, and blah blah. So I guess the health trajectory of people during the sinking of the Titanic was actually they were getting a little bit healthier before they started getting worse. So, but I think ice bath is like one of the perfect examples for that, on how it is quite obvious how you can incur damage by doing that too much, but just a little bit is fantastic.
Yeah, old naturopathic medicine, like one of the tool kits we had was hydrotherapy, and it was a big part because naturopathic medicine kind of was birthed out of nature cure and then herbal medicine, different things in Europe that merged together. And there was still a few, like one of the docs I met when I was in my first year, he was like 94 at the time, and he still had a property out in the desert, not too far from Tucson, Arizona, but he had all these old hydrotherapy machines, right, that were like museum-ish, right? You wouldn't see him. He had like a hot springs on the property, and back in the 60s he said he used to have like retreats there, and largely what they would do was diet and like contrasting hot and cold. But the key principle in naturopathic medicine with these old timers was alternating hot and cold, and always finish with cold, but like 30 seconds, a minute would be sufficient of that, right? So we don't need to prolong these things. If we do, we turn like a good stimulus into stress.
Especially, obviously, we are I mean, the science of, or the differentiation between men and women is, it's an understatement to say it needs to be explored more. But especially when we're talking about the more complex, hormonal makeup of a premenopausal woman, where we really don't know where we're meeting them in the cycle as far as like the instruction we're giving and the amount of stress that their body will respond positively to.
Yeah, and then I mentioned this earlier. Stress accumulates. So,
Yeah.
like as an example, I call it the multiple stressor problem. But there's a study I read before publishing my book 10, 11 years ago. But it was basically on Army Rangers. And one of the things that prompted the study is that they noticed before this study took place that after Army Ranger training, the recruits would often become fatter than they had been before. And so, part of the Special Forces training is being out in the field, exposure to, the elements, often cold, sleep deprivation, not enough food, crazy amount of exercise. So when I say multiple stresses, you've now just stacked stress on top of stress on top of stress on top of stress. And, so in this study, they measured hormone responses, body composition, and, they came in from the field with, depleted body fat, but completely dysregulated stress system, cortisol, thyroid, you name it. And then the aftermath was what's called body fat overshoot, right? They, were fatter after a month, 6 weeks than they were before going through that multiple stress problem. And eventually they recover, right? Because these are the most elite people, right? They're taking good care of themselves. But what we often, hear is like, oh, like there's a study on calorie restriction and it did this. And great. Well, what would happen if we sleep deprive someone and did that? And I can assure you, not good things. So.
Yeah, actually, one of the things that Anastasia, my wife, was the biologist that really is behind most of what we do is she actually, one of the things that she was involved in the study is something called FSP 128, which is literally something expressed in your fat, saying, you know what, that's too much. We're not doing brown adipose tissue anymore. We're going straight to white. We don't need that extra stress. So it's definitely very important. I really want to ask you a few more questions about usage, but before that, I did want to ask you about caffeine. So you do have caffeine in the formula as well. Is that because of what you mentioned? Is that because of that bottleneck of going through the different forms of B3 until we get to ATP?
Yeah, exactly. That's why we included it. And not a lot. There's, I believe it's 25 milligrams of caffeine, which, it would be about, a quarter of what's in an 8-ounce cup of coffee. And, so obviously we recommend the product be taken in the first half of the day, right? So that you wouldn't interfere with sleep. But we also recommend that because it does look like there's some circadian, body clock interaction with NAD and the metabolome, and not a lot to go on. But like as an example, one study, again in mice, because this is where most preclinical work is done, they infused the entire NAD molecule. I mentioned the NAD molecule orally is too big, but they infused it in. What they found was if they did it at the beginning of the activity cycle, so the equivalent for me, since I'm like on a normal sun schedule, like first thing in my day, it improved metabolic health. So think insulin, glucose, liver enzymes.
Yeah.
If they did it 12 hours later, it actually worsened those same things. And then as the next step in that study, they gave niacinamide and decided, oh, well, like that boosts NAD. Let's see what happens when we give that orally. And it was the same. So because of that, I just think it's prudent to do our NAD boosting strategies as early in our day as possible. So I know mine, I always do, within the first hour or two.
Fantastic. Me as well. I as well. The only thing is if I go to an infrared sauna, like later during the day, I'll do flash niacin before that. But so that was actually my next question. Is that product that in general you would want to take at the beginning of your day, at the first, quarter of your day, if you would?
Yeah. I tend to, so I have a strong belief that when we do something, is often as important as what we do. And, I think it's underappreciated with many dietary supplements. So quality of life would be the same. Obviously, quality of mind, our nootropic, are things that, are, I think, best stacked at the beginning of the day. We had talked about quality of skin before this. I think quality of skin is fine to take anytime, right? I kind of fit it in, usually at lunch personally. So, I think, paying attention to when we take things is important. And I know one of the things we do at Neurohacker is we'll usually make some prototypes up of a new product. I'm often, if not the first, the first couple of people that takes it is me, since I'm designing them. And when we made the prototype for Qualia NAD Plus, I did it for, I believe it was 20 days. It might have been 22 days. Measured my NAD levels before and after, and mine personally went up 156%.
Wow.
Right. So a big increase. So, and your mileage may vary. So, when we've done so far, the first cohort of a study, it's averaged more like 85%, some variance. But I was meticulous. I took mine literally first thing on waking with, I often do some kind of a hydration water. So I did that combo first thing in the morning every day. And I think that was part of the reason I had somewhat of a outlier high response.
What about the fact that you are at the time fasting? So is there any approach that you would take as far as stacking it again with other, I would call it just other lifestyle things? So if I know I'm going to exercise 6 hours later, when do I take that? If I didn't have my first meal yet, or if I know that I'm going to my esthetician today and they're going to do microneedling, what are some of the things that you account as far as when you're taking it?
So I don't, beyond just feeling like it's important to get it early in my day, both because of how I believe NAD is best used and the caffeine, I don't do too much with timing. There's no calories to speak of in it. There's nothing that's going to disrupt, a fasting, intermittent fasting routine. So, whenever someone wants to fit it in, I would just start. I think there's just, there's energy drinks and there's just caffeine laced everywhere. And I know a lot of people are, less aware of how caffeine affects them. So anything with caffeine, I would always recommend people bolus at least before noon. And then, say taking NAD first thing in the morning, right? So for me, that would be around 7 a.m. It's still going to be rising in the blood because, it's has to go through digestion, be absorbed. Then it goes through the liver and it's metabolized there and then slowly released into circulation. So if you, from when I take it at 7, it's probably not even peaking in my blood until about 6 hours later. And then descending from there. So the main thing is over time, doing it, say most days even, you'll build up the pool in all cells will be built up and just available whenever you need it to make more.
Interesting. Great. So this is as far as this is a standalone product. But what you do have is the senolytic product that you're only using, twice, 2 days out of the month, that is the protocol. Every 30 days you take 2 days and you're taking the senolytic product. You take 6 pills, a day. So within that period, would you ramp up NAD NAD consumption, but the NAD plus supplement beforehand? Do you just want to maintain a normal, supplementation habit? How do you look at it?
So I usually, on those 2 days a month that I take Qualia Senolytic, which for me is the first weekend of every month, just a few other people on our team do that, and I think I just told people that's an easy thing to remember for me anyways. And so that's all I do on those days in terms of taking any, capsules, supplements of our product line. And the way I would think of how NAD fits in, one of the things NAD does, because it helps. So when I think of cellular stress, I think of how cells respond is on a continuum. So what they'll first try to do is, if the stress is, say, moderate, well, let me become more resilient. I'll upregulate my defenses, be better protected against that. If stress is more or more prolonged or beyond a cell's ability to cope, it'll take some damage, right? And then you have processes like autophagy, right? That idea is that autophagy is going to go and recycle, kind of clean up some of that damage that happened to mitochondria or things inside a cell. But if the stress was even more, or cells were less resilient, that's when a cell could become senescent, right? Like it took on enough damage, it's no longer repairable. It's an irreparable cell. And so the goal for me is I want to make sure my cells have the resources the rest of the month to be able to not, or to be more resilient to whatever stress, metabolically, you name it, comes, so that they can adapt to it rather than have to become senescent. Yeah. So the rest of the month, that's part of how I think of my use of, whether it's Qualia Life, Qualia NAD plus, is that component. And the other part is our immune system, just so important to keep senescent cells manageable, right? So the rest of the month, things that help with immunity, which boosting NAD does, is a good strategy. So we don't have to like micromanage it. Our system smart. We just need to make sure we're giving it the resources it needs and trust that it's going to do the right.
Okay, fantastic. Do you take both Qualia Life and the NAD boosting formula, or how do you look at it?
So I've that original experiment that I did, I went off all of our products that had NAD3 for, I think it was 6 weeks, to get a good, like a true baseline, and then it only did the Qualia NAD plus during that. But my most normal routine is that I'll do, typically personally, 4 capsules of Qualia Life and then 1 or 2 of Qualia NAD plus, depending on if I think something, like I'm going to be, because of work, our whole team's going to Costa Rica coming up. As we're recording this, I'll be there next week. So I'm in Southern California now, but it's it's February, right? So the sun's not intense. It's going to be more there, and I know we're going to be outside. So I've been doing Qualia Skin every day, a little bit more, Qualia Life, Qualia NAD plus, so that my skin has the resources to deal more effectively with the stress of the sun that it's going to be exposed to, and didn't have a chance to slowly adapt to like I would normally have here as the days get longer and warmer.
Interesting. Great. I mean, look, Greg, this was a podcast full of rabbit holes that we could have gone on. So I appreciate the general direction that we gave. If that would be one supplement that people would take, how would you say, because some people, it's not even about budget. I call it attention budget. You can't take all the supplements in the world, right? How would you combine it with the nutrition? Is that something that you could support with different nutritional input? For example, we met guys, don't drink 1,000 glasses of red wine because you want more resveratrol. Okay, but what are some of the nutrition advice that could go around supporting NAD and that product specific?
Well, I think there's the NAD, basically that metabolome, it's just much more bioavailable in animal products, right? So for people doing animal products, you're going to get good support by just eating high quality eggs, dairy, grass-fed, pastured meat, depending on what a person responds best to. For the vegans, vegetarians, part of the reason that vitamin B3 deficiency was originally discovered was because the corn culture, right? The Native Americans that used that as a staple food they would process it with alkali lime in a specific way, which unbinds the bound niacin and makes it more bioavailable. And in the turn of the 20th century, corn was being consumed widely, but that step wasn't being used. And so even though there was sufficient in theory. Niacin in the corn, it wasn't bioavailable that caused that, right? So for people that are, a more plant-based diet, then it's harder. And then, like I said, even with maintaining the same diet as a 20 or 30-year-old, when we're 50 or 60, we're not making use of that to have as much. Like as an example, I mean, part of the reason my NAD levels went up 156% is because, without doing quite NAD or something that's giving me extra precursors, etc., mine are somewhat age reflective, and I'm in my 6th or 7th decade, right? I'm 62 now, right? So I just can't get there through diet and good lifestyle to maintain, what would be equivalent to at least the testing service I did at the time was Ginfinity, was the name of the lab, and to be in their optimum range, what they would set as like, a healthy level of, like an 18 to 25-year-old person, I have to supplement. It's just not achievable with like diet lifestyle.
Yeah, I mean, I'm thankful for Ginfinity for that very readily available test. It definitely opened a whole new world of proving NAD supplementation. Maybe last question: what should people feel? Because again, one of the greatest things about the Qualia series of products is the fact that you can feel it working, whether it is skin product looking better, whether it is Qualia mind, your mind is more clear, there's less brain fog. What can you feel when you're taking NAD?
So one of the things that we did before we moved into market is we asked it's basically a subjective questionnaire that has to do with things that are normally experienced as men and women get older. And the two questions that the most consistently improved, one was just think of energy writ large, right? People feeling like they had more energy. The other wasn't sleep in the sense, it was sleep. It wasn't sleep in the sense of like falling asleep or sleeping longer. It was feeling like they either needed less sleep or were less fatigued from not getting a good night's sleep. So again, like somewhat slotting into that energy, but in more that sleep context. So those were the two main areas. But then we saw, quite a few others just not as consistently across the board. But energy would be by far like one of our like a friend of Neurohacker Collectives is someone named Scott Barry Kaufman, pretty famous author, and and when was it? Anyways, I made sure to get him some Qualia NAD sometime, I want to say like Thanksgiving-ish, like in that time period. And about a week later, I just got, a short email, and it just one word, energy with like 3 exclamation marks, right? So it's like, oh, I guess you're noticing it. So,
and then I know that Scott Barry Kaufman wrote a 1-letter email.
Yeah.
Well, that's great. So, where would people go to get this product specifically and the entire Neurohacker Collective product line?
Yeah, so we're neurohacker.com. I would suspect in the show notes there may be
yes, for sure.
Share. And then the best place really to follow us is on Instagram. That's our primary one. Though recently I took over our Twitter handle from social media, mostly because it was neglected, and I'm a big fan of X, and so I was given the free reign to that. So if you see any postings on X, they're probably me, but they're going to be more nerdy. They're going to probably.
Go ahead.
I said they're going to be more nerdy, right? They're going to be more studies and things like that. So I'm interested in.
There's no chance of finding you dancing on TikTok. That's what you're basically telling me.
No, I've never. I think I've never. I'm not much of a social media person, anyways. But X, I'm a fan of. Just because it seems a lot of people I respect a lot share great content on X. But no, I've never. I've never downloaded Twitter or done that.
TikTok,
yeah. Oh, sorry, TikTok, yeah.
Yeah, great. I mean, again, I couldn't recommend you guys' product more. I believe you did a great service for me as an individual. So I appreciate the work that you do. We will obviously have all the links in the show notes. We're going to have basically a synapse of if anyone wants to get to a specific time stamp in this podcast and kind of revisit it. I highly recommend doing that because, again, you can go to a lot of rabbit holes from this conversation. And I super appreciate you, Greg. Dr. Greg Kelly. I'm very happy that we got you on the podcast finally.
Well, thanks for having me. It was a pleasure, and look forward to seeing you in a couple months' time at the Biohacker Conference.
All right. Thank you very much, and have a good rest of your day.